For decades, the global perception of India was defined by the back office. It was seen as an engine room where workers wrote millions of lines of code to maintain systems built by foreign corporations. This model created a lucrative industry, but it also created a strategic vulnerability. A nation cannot operate as a global power if its critical infrastructure, from smartphone operating systems to financial networks, is owned by outside entities. That realization sparked the Indian Technology Booster. This initiative moves the country away from being a technology consumer toward becoming an independent developer of semiconductors, space infrastructure, and AI. Geopolitical sovereignty in the 21st century is determined by who owns the foundational hardware and data layers of a society, not just who operates them. The first step to sovereignty was building a digital ground level no foreign corporation could control. This is the digital public infrastructure. Look at these QR codes at a basic retail stall. Instead of relying on Western credit card processors, India built UPI, a homegrown payment network that handles billions of instant, zero-fee transactions directly between local bank accounts. This financial network is integrated with Aadhaar, a biometric identity system. By pairing a physical ID with a fingerprint or iris scan, the country created a closed-loop ecosystem where citizens authenticate their identity and access services without touching a foreign server. The transmission layer for this data is expanding at a high speed. By early 2026, over 5.23 lakh base transceiver stations were installed, bringing homegrown 5G coverage to 99.9% of the country's districts. By securing the layers for payment, biometric identity authentication, and sovereign data transmission, India built the foundational ground required for much more advanced technological innovation. Even a perfect software system is vulnerable if the physical microchips it runs on are designed and manufactured by an external supply chain. To address this hardware gap, the government launched a 1.64 lakh crore rupee semiconductor mission. The goal is to build a domestic ecosystem for manufacturing and packaging that can resist international supply disruptions. This is a schematic of the Vikram 32, an Indigenous 32-bit processor designed for space applications, proving the country can engineer the logic cores necessary to power its own hardware. This hardware development is paired with a skilled workforce fueling artificial intelligence. These systems are now applied to healthcare diagnostics and agriculture, processing local data on local silicon. Building these processors domestically ensures that foreign trade restrictions cannot choke off the growth of India's AI research and application. Sovereignty on the ground requires sovereignty in orbit. Relying on foreign satellite systems for navigation remains a significant strategic risk. To mitigate this, India developed Navik. This independent navigation system is designed for disaster management and strategic applications, ensuring that positioning data remains accessible regardless of external diplomatic or political shifts. This integration is enabled by an Indigenous 28-nanometer baseband chip. It is designed to process Navik signals, directly linking domestic semiconductor design with orbital infrastructure. Launching these systems requires heavy lift capabilities. Recent testing of Indigenous semi-cryogenic and cryogenic engines has validated the thrust needed to deploy these massive payloads into orbit. The combination of sovereign silicon and heavy-lift rockets means India can navigate its territory and deploy orbital assets without requiring permission from outside powers. Protecting this new infrastructure requires anticipating the technological threats of the next several decades. The country is scaling its supercomputing power to handle the high-performance calculations needed for climate modeling, drug discovery, and advanced AI research. At the same time, investments are being made in quantum technology, with a focus on quantum cryptography to secure data against future decryption methods. These frontier technologies act as a defensive shield, ensuring that the digital infrastructure built today remains secure against the computing power of tomorrow. It is easy to view a payment system, a microchip, and a rocket engine as separate achievements. In reality, the true strength of the booster comes when these systems begin to overlap. As these sectors overlap, they create an integrated network. Supercomputers design chips, communicating over 5G networks guided by satellite data. This creates an exponential multiplier. A breakthrough in one field upgrades the space, 5G, and AI sectors simultaneously. The role of the passive consumer has been replaced. Today, India is exporting its digital infrastructure model to other nations and putting its own microprocessors into the upper atmosphere. With 12 approved semiconductor projects and the global adoption of its digital public infrastructure, India is now engineering the same foundational tools it once had to import.